Okay, hello, and thank you for participating in today's webinar, Pharma 4.0 Demystified, as we work to peel back some of the layers of the onion that is Pharma 4.0 and unveil how it can help manufacturers in the life sciences industry benefit from the efficiencies that it's meant to bring about. Before we get started, I'd like to offer a few tips to make sure everyone gets the most out of today's webinar. First off, it's easy to get distracted, especially as a lot of folks are very busy and some are still working from home. Phone calls, texts, chats are all hitting us at a mile a minute, so please do your best to stay focused and engaged if you can. Next, take notes. If you find something we discussed today particularly interesting, jot it down so that you remember it for later. And if you have any questions that come up throughout the webinar, enter them into the chat. We'll be collecting them for later at the Q&A after the presentation. Finally, we've added a couple of poll questions to keep things interactive. Please answer them as best as you can, reflecting your current circumstances as they pertain to Pharma 4.0. Here's a brief agenda as to what we're going to discuss today. First, we're going to take a look at Industry 4.0 and what exactly that term means, and then we'll introduce the concept of Pharma 4.0 and how it relates to Industry 4.0. Look at how these two concepts can help improve the operations of a life sciences facility, and we'll walk through some of the technologies out there that may apply. We'll also tie use cases to the technologies and talk through some potential watchouts and pitfalls to avoid when considering the implementation of digital technologies. Finally, we'll wrap up with a discussion about digital strategies and directions to take on your digital journey. Okay, let's get to it. But first up, introductions. My name is Bryon Hayes, and I'm the Director of Smart Manufacturing Solutions at Grantek. I've been with the company for 20 years, starting out as a fresh-faced engineer straight out of school. My career has grown with the company and has been primarily focused on the life sciences industry, where I've implemented and managed countless automation and information projects. As the SMS Director, I manage a portfolio of productized solutions that are focused on the pharma, biopharma, and med devices industries. I'm actively engaged with the International Society of Pharmaceutical Engineers, or ISPE, especially in Canada, where I'm based. And I've been involved in their Pharma 4.0 special interest group for about 4 years. Now for our first poll question. The question is, what does Pharma 4.0 mean to you? Do you believe that it's simply a buzzword created by marketing people to sell technologies? Do you think that it involves becoming digital while staying compliant to industry regulations? Is it a new business model where the IT department runs the show? Or are you so unsure about Pharma 4.0 that the term hasn't resonated with you yet? Okay, go ahead and vote now. Okay, I'm seeing some votes come through. Looks like about half of the audience has voted. Give you a couple more minutes. Okay, looks like the top answer with 65% of folks who voted is going digital but staying compliant. So that's good. It looks like most people have a good bead on Pharma 4.0 and just what it means. So that's great news. Okay, so we're going to start with a sound foundation and introduce the fundamentals of Industry 4.0 first to make sure that we're all on the same page and we have the base knowledge we'll need to understand Pharma 4.0. As I kind of alluded to in one of the poll answers from earlier, all this 4.0 talk does seem like a little bit of a buzzword because it gets used in marketing material all the time, but it's also a real thing. It's related to the concept of digital transformation. So I wanted to take a quick step back to talk about that concept first. The first thing to know is that digital transformation is a word to describe how connected technologies are changing businesses around the world. And we should keep in mind that digital transformation is happening everywhere, not just in manufacturing. It's happening in industries like banking, healthcare, education, government, and elsewhere. From one industry to the next, digital transformation looks very different, and it can look very different from one sector to the next within an industry. For example, digital transformation to a food and beverage company looks very different from that of a pharmaceutical company. And that leads us to Industry 4.0. I personally like to differentiate between digital transformation and Industry 4.0, where Industry 4.0 is specific to manufacturing and industrial systems, whereas digital transformation applies to all industries. So the term digital transformation, the diversity of it across industries, and Industry 4.0 is one thing. The second thing is to keep the speed of digital transformation in mind as we talk about it. What I'm showing on the screen is the timeline for the first, second, and third industrial revolutions. And what you'll notice is that the time frame between industrial revolutions has been decreasing. Walking through that, the first industrial revolution was in the 18th century when we started using steam power. It took 1.5 centuries for the second industrial revolution to happen when we started using electricity. It was less than a century after that for the third revolution, which was when computer technology and PLCs started being used to automate. And then less than a half century after, the fourth industrial revolution began. So there was a 1.5 century gap, then less than 1 century gap, then less than a half a century gap between revolutions. The point is, we've never experienced change that's this big and diverse and happening this fast, which means we need to move faster, we need to experiment and fail and re-experiment more often than we ever needed to before. To help illustrate my point that Industry 4.0 is a subset of a larger overall digital transformation, I wanted to show this image. The author's original intent was to highlight how Industry 4.0 is a branch of a larger tree that they call the Internet of Things, which is also a somewhat buzzwordy topic. Essentially, it boils down to more and more things being connected together and sharing data. These connected things are also typically labeled with the word smart. So you can see we have a mesh network of smart things all connected. There are smartphones, smart cars, smart power grids, smart homes, smart appliances, smart meters, and so on. And you have the smart factory with smart devices as being part of the cloud over there on the right called Industry 4.0. The next thing I wanted to explore is how Industry 4.0 gets defined. When you research Industry 4.0, there's basically two ways it's described. The first is a technology-based definition. I'll start with this one, even though it's not really my favorite. The technology-based definition of Industry 4.0 usually looks like a list of random futuristic technologies, things like digital twin, autonomous robots, artificial intelligence, augmented reality. That stuff's always on the list. The one reason I don't love this technology-based definition is because the list is always changing. Technologies that apply are different from one industry to the next. So it's not the best way to think about Industry 4.0. It's sort of a moving target and not really the way I like to think about it. Something you should notice about that, though, is that all of the technology on the list is based on connectivity throughout the plant and throughout the enterprise. That's actually the main differentiator between Industry 3.0 and Industry 4.0. For automation during Industry 3.0, we didn't need widespread connectivity, but for Industry 4.0, we do. It's actually completely based on connectivity, and that's really important to recognize. The other definition is a business value-based definition, and I think this way of looking at Industry 4.0 is way better, and I like to visualize that definition in 4 steps. First, I imagine each facility has had the automation systems 100% integrated with the business systems, like an ERP. That's referred to as vertical integration. This would mean when a production order comes in, you don't need to go into the ERP system to see it and then figure out which line to run it on. All that happens automatically, but also do things like quality and downtime monitoring automatically. The second part is horizontal integration, which is across the value chain. So for this, Imagine that the systems automatically knew when you were running low on raw ingredients and placed orders. It could also track which raw materials went into which batches and could track it all the way down to the individual finished goods that go out to the customer. The third and fourth steps are to automate all of that together so it's all happening automatically, and then have the systems optimize themselves when something changes. A simple way to put this is to imagine a manufacturing business where people were not running it as much as they're monitoring it and tuning it. It's admittedly a little futuristic and we're not there yet, but experts genuinely believe that's the direction that technology is driving us towards. So if you humor me and envision an Industry 4.0 business in that way, now we can ask ourselves what the benefit to the business is. How is a self-optimized business better? Well, there's two things. One is that there will be less waste, less downtime, and that leads to higher profitability. The other big benefit, perhaps the bigger benefit, is agility. So imagine something sudden happens, let's say demand suddenly drops or something like COVID happens again. The entire business can react really quickly and refactor what it's doing. That real-time agility and responsiveness is a huge benefit. It could be the difference between one company going out of business when something changes and another surviving and adapting. Out of all of this, there's two observations I want you to see. And what I want to do here is connect the technology of Industry 4.0 to the business value. Remember that much, if not all, of the Industry 4.0 technology is based on connectivity. And remember, the future business value of Industry 4.0 is efficiency and agility. The picture I want to paint here is that no matter what Industry 4.0 thing is going to be right for your organization, or when the right time will be to work on it, you're going to need connectivity. Maybe you'll want cloud next year, or maybe you'll want big data 3 years from now. And no matter what, you'll need that connectivity. So you could view this as an opportunity. You've probably heard the phrase, you want to skate where the puck is going, not where it is right now. Well, if you apply that thinking here, the puck is going towards Industry 4.0. So doing things like connectivity now so that you're ready in the future, it's going to get you ahead of your competitors, and that's an opportunity. You can also look at this through another lens, which is a little scarier, and that's survival. The CEO of Accenture previously stated at the 2016 World Economic Forum that digitalization is the main reason over half of the companies on the Fortune 500 list have disappeared since 2000. So competitive advantage is a good reason to invest in connectivity, but simply surviving through Industry 4.0 might even be more compelling. All right, so now that I've scared you a little bit with the introduction of Industry 4.0, now let's take a look at Pharma 4.0, just what it is and how it relates to Industry 4.0. So members of the ISPE, keen to establish a framework for adapting digital strategies to the unique operating environment of pharmaceutical manufacturing, formed the Pharma 4.0 Special Interest Group, and in 2017 released the Pharma 4.0 operating model. You can see the operating model here. It's divided into 4 discrete areas: resources, organization and processes, culture, and then information systems. You'll notice that only the latter is directly technology focused. The other 3 are focused on the manufacturing organization itself, its people, processes, and culture. In addition, at the top and bottom of the model are 2 what are referred to as enablers: digital maturity and data integrity by design. These are key to establishing a sound digital strategy that will work for a pharmaceutical company's unique regulatory compliance needs. Along with the operating model, the ISPE Pharma 4.0 Special Interest Group introduced these 12 theses for Pharma 4.0, which you can see on screen now. The Special Interest Group emphasizes that Pharma 4.0 extends and describes the Industry 4.0 operating model specifically for medicinal products. Different to common Industry 4.0 approaches, Pharma 4.0 embeds the best practices required to meet regulatory requirements. Pharma 4.0 breaks down silos in organizations by building bridges between the industry, the regulators, and all the other stakeholders, including the patient. For next generation medicinal products, Pharma 4.0 is the enabler and business case. For established products, Pharma 4.0 offers new business cases. Investment calculations for Pharma 4.0 require innovative approaches for ROI and cost justification. The prerequisite for Pharma 4.0 is an established pharmaceutical quality system and controlled processes and products. Pharma 4.0 is not an IT project. The operating model also includes organizational, cultural, process, and resource aspects. The operating model allows for the realignment of an existing operating model to achieve an appropriate desired state. Pharma 4.0 is not a must. It's a competitive advantage. Not doing it might be a business risk. And when moving from blockbuster products towards niche products, Pharma 4.0 offers new ways to look at your business case. Essentially, they boil down to this. Pharma 4.0 embeds quality and regulatory requirements into Industry 4.0 to meet the needs of the industry. It goes far beyond the world of IT and focuses on the entire holistic organization, and it provides new ways of looking at the business of pharmaceutical manufacturing. To emphasize those 12 theses as the driving impetus of Pharma 4.0 and its holistic way of looking at manufacturing in the life sciences industry, the Special Interest Group created a series of working groups, each of which focused on a specific area of the common mission. Here is a list of those working groups direct from the ISPE website. I'm not going to read them all out, but you can see that there's a broad variety of topics covered by the Pharma 4.0 Special Interest Group. Now let's dive into those two enablers from the Pharma 4.0 operating model. First, we'll talk through digital maturity. As the Pharma 4.0 operating model and the 12 theses makes fairly clear, Pharma 4.0 takes a holistic approach to the implementation of digital technologies and a digital mindset within a pharmaceutical enterprise. This brings us to the concept of digital maturity, which is in essence a measurement of an organization's position along a spectrum that ranges from, on one hand, just dipping their toes in when it comes to the use of computers and automation, all the way to a completely digital, autonomous plant that adapts on its own to changing manufacturing conditions on the other end. There are many ways to measure digital maturity, but two common indices are the Industry 4.0 Maturity Index created by ACATECH and the Digital Plant Maturity Model created by the BioForum Operations Group. Let's look at these now. ACATECH, the National Academy of Science and Engineering in Germany, published this study in 2017. They realized the road to Industry 4.0 will be different for every company, and it is therefore necessary to begin by analyzing each company's current situation and goals. What are the company's strategic objectives for the next few years? What technologies have already been implemented? The ACATECH Industry 4.0 Maturity Index is a 6-stage maturity model that analyzes the capabilities in the areas of resources, information systems, culture, and organizational structure that are required by companies operating in a digitalized industrial environment. The attainment of each development stage promises concrete additional benefits for manufacturing companies. The model's practical application was validated in a medium-sized company. The image here is directly from the study. It makes the 6 stages of maturity clear, moving from computerization through to connectivity, visibility, transparency, predictive capacity, all the way to adaptability. At phase 1, different information technologies are used in isolation, and at the opposite end of the spectrum, self-optimizing systems are integrated to allow the delegation of decision-making to digital systems in response to changes in the operating environment. As opposed to the ACATECH study, which is industry agnostic, the Digital Plant Maturity Model, or DPMM, was created by a collection of biopharmaceutical manufacturing organizations, the Bioforum Operating Group, to provide a common framework to be used across the biopharma manufacturing industry. This model uses 5 levels that characterize the different stages of digital maturity of the plant and its relationship with the wider value chain. The levels range from the pre-digital plant all the way to the adaptive plant. The descriptors are slightly different than the ACATECH model, but the overall concept is similar. This model is slightly more granular than ACATECH in regards to the areas of the organization that it describes. There are multiple areas or dimensions that are generally classified into categories: business capability and enabling capability. The business capability dimensions category includes the primary business capabilities required to design, build, operate, and maintain the digital plant and its role in the end-to-end enterprise value chain. These capabilities are manufacturing automation and process execution, lab execution and quality management, manufacturing support, and production planning and supply chain. The enabling capability dimensions category includes the people, processes, technology, and information capabilities required to enable the above business capabilities. These capabilities are people and culture, business insights and analytics, end-to-end value chain integration, systems interoperability and governance, and IT security and operations. Okay, so now we have our second poll question. The question is, where do you think your plant lands on the digital maturity scale? Are you a pre-digital plant? Do you have digital silos? Are you connected? Are you predictive, or are you adaptive? Okay, go ahead and vote now. Okay, I'm starting to see some answers come through. I'll give you another minute for any stragglers to come in. All right. Well, it looks like the answers are spread across all of the categories. Looks like we've got a few pre-digital folks, some digital silos, a few connected plants, no predictive plants, but a couple actually answered that they're adaptive plants. So very interesting results. Thanks everybody for voting. That's the last poll question for this presentation. All right, moving along, we'll talk about the other enabler in the Pharma 4.0 model, and that's data integrity by design. It's important for the industry to shift the perception from seeing processes as separate from the current supporting and related downstream technology, and to look at the processes and the supporting systems as tightly integrated. It's important also to consider and care as much about how data will be used or interpreted as about how it's created. This requires all of us to improve our understanding and accept that we must continue to develop our knowledge of data-related technology. Data integrity is much more than ensuring that your system has an audit trail. It's about ensuring that you have quality data, that we are gathering the right data and metadata, that we're considering the entire data lifecycle from creation all the way through to destruction, and that you're upholding Alcoa Plus principles. Data integrity requires well-defined, robust, repeatable, but flexible processes. It also requires that risk management principles are taken into account, and it requires that you use critical thinking when designing and deploying systems. So now let's look at where Pharma 4.0 and Industry 4.0 intersect. This handy Venn diagram created by the folks over at Tulip shows a few examples of the overarching technologies and concepts inherent in Industry 4.0, as well as those of Pharma 4.0. The common theme here is that at the intersection of Industry 4.0 and Pharma 4.0, both regulatory compliance and continuous improvement are supported through the move from traditional processes to the world of digital. A few examples of this possibility are continued process verification, a paperless plant floor, digital validation, and near real-time batch release. So, how does Industry 4.0 and by extension Pharma 4.0 benefit manufacturers, specifically in the life sciences industry? To measure the full benefits of Industry 4.0 in manufacturing companies, McKinsey experts evaluated the impact of its adoption on 8 corporate value drivers, which are presented in the image on the left. The data they collected indicates that Industry 4.0 implementation led to a 3 to 5% increase in productivity, a 30 to 50% reduction of total machine downtime, and up to 85% increase in forecasting accuracy. The data relative to productivity and machine downtime is also confirmed by a KPMG report on Industry 4.0 in the manufacturing industry, which found 3 to 5% increase in productivity and 20 to 35% reduction in total machine downtime. As the level of Industry 4.0 maturity of those manufacturing companies probably improved since the original study in 2015, the current benefits are probably even more significant. Another study found that data collection across the supply chain and full machine-to-machine and machine-to-cloud communication has increased earnings by between 2 and 5%, depending on the supply chain complexity. In addition, a 20 to 30% increase in customer satisfaction has also been reported after Industry 4.0 implementation. So narrowing the lens to look exclusively at Pharma 4.0, things get a little cloudier. Although quantitative data on Pharma 4.0 benefits is lacking, current literature and a series of stakeholder interviews on the matter revealed that benefits similar to those mentioned on the previous slide can be expected in the life sciences industry specifically. For instance, implementation of Industry 4.0 technologies could allow real-time quality control of the production process and immediate correction of any deviations observed. Thus, Pharma 4.0 could prevent the loss or long-term quarantine of entire production batches that sometimes happens in processes that rely exclusively on post-production quality control and batch release. Overall, 4 distinct areas have been identified as to where Pharma 4.0 can provide significant improvement. These are performance and productivity, improvement of production processes, flexibility, and employee productivity. Competitiveness, the improvement in market positioning as compared to that of other companies. Regulatory aspects and socio-environmental responsibility. You have better data traceability and waste reduction, among other things. Organizational culture and strategy. You get better governance, illustrated by an optimized organization and use of administrative resources. The efficiencies offered by Pharma 4.0 technologies exist across the entire enterprise in the value chain. So we've broken these down into a few different categories. First, you have engineering efficiency, enhancing the design phase. Next are operations efficiencies, which we've broken down into performance, maintenance, information, and energy efficiencies. And finally, there are service efficiencies, which are focused on how you interact with your customers, the patients. We're going to focus on the first two categories today. There are many technologies that can bring about engineering efficiencies. The first one I want to discuss is building information modeling, or BIM. BIM is a highly collaborative facility design process that allows architects, engineers, contractors, manufacturers, and other stakeholders to plan, design, and construct a building within a single model. BIM extends beyond 3D modeling into 7 dimensions. The fourth dimension is time-related information, so construction sequencing by means of Gantt charts and timelines. The fifth is cost analysis, cost management, construction cost estimating, and so on. The sixth is sustainability, environmental, economic, and social sustainability impact studies. And the seventh is life cycle and maintenance information, the planning and management of maintenance operations throughout the building's life cycle. BIM is a very powerful tool. Another powerful tool is the use of augmented and virtual reality. These technologies support remote collaboration and extend traditional video conferencing tools to enable an immersive experience. Users can interact with facilities, equipment, and so on as they're being designed. This also allows for virtual acceptance testing. The use of wearable devices such as smart glasses, as well as mobile devices such as tablets, helps in this regard. Finally, 3D printing, also known as additive manufacturing, allows for rapid design and prototyping of small pieces and parts quickly and cheaply, expediting the engineering of those sorts of things. With regard to operational efficiencies, we've grouped a number of technologies on this single slide that act as enablers for more specific applications to sit on top of or use. First, you have the cloud of software as a service. These are compliant applications delivered to the people who need them anywhere they are. Then you have biometrics for authentication. This is an enhancement for data integrity. It's stronger than just a simple username and password. It's linked to the individual. Then you have data warehouse, data lake, and data fabric. This is a single source of truth that breaks down silos between sources of data and information. Then you have the industrial Internet of Things and wireless technology. This enables true mobility of equipment, real-time location tracking, energy monitoring, and so on. It allows more devices to be connected, more data, better analytics, and better decision-making. It also enables a lower total cost of installation for things like environmental monitoring, energy monitoring, and predictive maintenance. Then you have control towers. These enable the ability to see multiple data sources in one place through multiple dashboards. Environment data, production data, maintenance data, quality data, and more can be grouped together on a single pane of glass. Finally, we have mobile and wearables. In addition to the engineering efficiencies, they allow digital work instructions and SOPs to be held at the user's fingertips or in front of their eyes, and they can be an enabler for things like paperless validation. Now I want to get into some specific applications, and first off, I want to discuss manufacturing execution systems, or MES. MES has been around for decades, so most people don't consider this application set to be part of Industry 4.0 or Pharma 4.0. However, it is an enabler for both vertical and horizontal integration. connecting the value chain from materials entering to finished product leaving. It can drive efficiencies in the areas of quality, production, maintenance, inventory, and more. Some examples of MES applications in the life sciences space are electronic batch or device history records, release by exception, weigh and dispense, materials management, equipment management, digital work instructions, and many more. The benefits of an effectively implemented MES solution for pharma manufacturers are numerous. They include improved scheduling and resource utilization, improved manufacturing flexibility and process changeover, reduced work in progress and improved material tracking, reduced production record errors, whether it be electronic or a hybrid electronic paper, enforced sequence of operations, minimize quality issues, shorter production cycles, and many more. Next, I wanted to chat a little bit about automated vehicles. These robot or cobot-like mobile units can drive efficiency in material handling applications. I have here two examples of automated vehicles: automated guided vehicles, or AGVs, and autonomous mobile robots, or AMRs. AGVs are larger and are typically used for heavier payloads where forks are needed. They have minimal intelligence on board and travel via fixed routes, navigating through LiDAR. If you want to change the route of a vehicle later on, you need to reteach the vehicle. We've used them for moving around large containers of liquids, powders, or in-process product. AMRs are typically used with smaller payloads that can be picked up from underneath. They are more intelligent than AGVs and have more sensors and cameras on board. They can travel on flexible routes and will maneuver around obstacles. We've seen them used for moving small parts and small containers of raw materials around. Next, I'd like to discuss RFID, or radio frequency identification, as well as real-time location tracking. RFID enables you to read and write data onto a small tag that can be affixed to a container of product, a piece of clothing, a tool, a piece of equipment, and then you can use that data for a multitude of purposes. Some of the benefits of using RFID in the pharmaceutical supply chain are that it can enable the enforcement of product authenticity and combat counterfeit pharmaceutical products. Counterfeit and compromised drugs pose a major risk to public health. With RFID tags, the digitally generated unique code data programmed by the manufacturer, which is difficult to duplicate and cannot be easily altered. This provides an enhanced level of product security in the supply chain. RFID also bolsters effective inventory management. Real-time inventory tracking and management in the pharmaceutical supply chain is critical to ensure the safety of the product. RFID improves inventory accuracy for distributors and retailers and reduces the risk of a shortage of essential drugs. By keeping tabs on the limited expiry dates of the products, the technology helps in the effective implementation of first expired, first out in warehouses. RFID can also support better management of drug recalls. In the event of a drug recall, RFID tags can identify the exact product loads that have been recalled and trace their movement in the supply chain. And it enables tracking and maintaining cold chain logistics. With RFID solutions, such as an RFID portal positioned at the entrance to temperature-controlled areas, temperature and humidity monitoring in warehouses is more efficient compared to manual monitoring. An automated cold chain using RFID reduces the risk of human error that cause expensive product wastage in the supply chain. Expanding on RFID is location tracking, which uses a multitude of technologies, the most common being Bluetooth Low Energy and ultra-wideband. Each of these technologies has its benefits and areas of concern, but location tracking, especially in combination with automated vehicles, can unlock many potential efficiencies in logistics. It enables you to pinpoint the location of an asset in real time, sort your assets by a number of parameters, analyze the routes of transit of an asset, display workflow data, or trigger alerts via geofencing. Next, we'll move into the world of analytics and AI. We'll start with advanced analytics. Advanced analytics is the conversion of raw, unstructured data into organized, in-context information that is crucial for informed decision-making. Analytics exists in a multitude of flavors and degrees, from descriptive, or describing what has happened in the past, all the way through to prescriptive, recommending a course of action for the future. Advanced analytics is an enabler for the optimization of many processes, such as CIP, and other bioprocessing operations. It is also a key enabler for continued process verification, the prediction of product quality, and deviation monitoring. AI and machine learning go beyond the statistical modeling used by traditional analytics applications. This technology is key to predictive and prescriptive efficiencies, driving things like predictive maintenance, using models to recognize when a motor might fail due to its vibration signature, or even predicting batch quality issues due to external factors before the batch even runs. Here I'm showing two examples of platforms we've seen used in this space. The first is Cognex's ViDi deep learning vision software, which takes machine vision to the next level. ViDi makes life so much easier when you need to identify defects on very small or very similar parts, like vials. Quartic AI is an open AI platform that lets you deploy AI and machine learning models to drive insights into the manufacturing process that may previously have been hidden. So, everyone's excited about technology, but remember, technology is only one aspect of Pharma 4.0. As with any change, technological or not, it is important to keep people at the heart of the process. Technology is a key enabler of digital transformation and should be one area of focus of any Pharma 4.0 strategy. However, to ensure everyone sees the value in digital transformation, it's essential that people remain at the heart of your change management plans. Research suggests that 70% of organizational transformations fail, in large part due to poor communication and a lack of buy-in from teams. The lesson for business leaders is, bring your people with you. So when it comes to setting out your Pharma 4.0 roadmap, it's essential to engage with your leaders and employees and involve all departments in the decision-making process. Plan for process change. Digital transformation is already improving throughput, efficiency, quality, and visibility across the pharmaceutical value chain. To realize the full potential of connected technologies for process optimization, it's therefore important to consider how workflows may evolve in the future and adopt the right solutions to facilitate this transition. Integrated platforms bring data together in a meaningful, organized way, simplifying retrieval and allowing operations to be managed as a single workflow. These data management solutions also enhance and maintain the integrity of information by eliminating transcription and making data securely accessible to authorized users. For example, in a QC lab, with equipment connected via a laboratory information management system, or LIMS, laboratory professionals can download instrument parameters direct to the equipment itself, eliminating the errors associated with manual setup and making analysis faster. Everybody wants a quick win, but truth be told, when you're thinking strategically, quick wins aren't necessarily the best course of action. The key to a successful Pharma 4.0 strategy is to evaluate your digital maturity, figure out where you want to go, chart the course, and steer your organization in that direction. I've said all of these things before, but I want to reiterate because they're key to success. Know your processes, evaluate your digital maturity, create a roadmap, get all the departments involved. Remember, Pharma 4.0 is not an IT project. And finally, get support from across the enterprise. You need support from everyone from the operators to the leaders to ensure success. So to summarize, here are a few key takeaways. Digital transformation applies across all industries. The future business value of Industry 4.0 is efficiency and agility. Digital maturity and data integrity by design are two very important aspects of Pharma 4.0. Organizations should evaluate their digital maturity in order to understand how to further improve. Data integrity requires well-defined and robust processes, risk management principles, and critical thinking. Both Industry 4.0 and Pharma 4.0 support regulatory compliance and continuous improvement simultaneously through digital transformation. Pharma 4.0 implementation and related Pharma 4.0 technologies add value to your organization. Keep people at the heart of the process. And consider how your workflows may evolve in the future and adopt the right solutions to facilitate this transition. Okay, now I wanted to open up for questions. You can enter your questions into the chat. Okay, I've got a question. It says, you mentioned wireless, but I've been hearing a lot about 5G. Have you seen companies deploying 5G at all? So there's two flavors of 5G. There's the public 5G and private 5G. And what I'm seeing today is companies investigating or wanting to use public 5G just to enhance mobility, going beyond the established 4G technology. What I'm hearing about is companies wanting to look at implementing private 5G as an alternative to Wi-Fi to enhance connectivity with more and more devices and sensors. And I personally haven't seen it deployed yet, the private 5G especially, but I've heard it's being done now. Okay, I've got, it says, have you talked about using, you talked about using AI and machine learning. How do these technologies impact validation? This is actually a great question. I'm working with a couple of my fellow ISPE colleagues on an article around using AI for continued process verification. And we actually received some editorial commentary from the GAMP subcommittee because we mentioned, that there's no single AI model lifecycle strategy for manufacturing where a model is built, qualified, and validated into a specific process. But they've come back and said, no, there's been significant movement in this regard. There was an AI special interest group formed by ISPE in 2019. And ISPE has also provided some good practice guidance in their recently published ISPE GAMP good practice guide enabling innovation. And there's also been a number of studies done as to how to qualify AI algorithms. So while there's no official standard out there for validating AI, it's being done and it's being used in industry today. Got a question, are there regulatory guidelines from the EU, FDA, or Health Canada for Pharma 4.0? And the answer is, at least as far as I'm aware, there isn't anything specific to Pharma 4.0. The, ISPE's GAMP guidance, around design and qualification of information systems is still the best place to turn for guidance around the deployment and the qualification of those systems. Another question here is, how do I get started quickly? As I mentioned a little bit earlier in the presentation around quick wins, and there not really being any quick wins. Well, I mean, if you already have an established strategy, the quickest way to move into the digital world would be start doing some proof of concept and proof of value exercises where maybe you take a small subset of your process and apply digital there, or you apply it to let's say all of your tablet presses, or you apply it to one bioreactor, and then you prove proof of value and the proof of concept, and then you move into deploying that across more and more pieces of equipment, and then across the entire enterprise. Jumping from pre-digital to fully adaptive is definitely not something you do in one swipe. So thanks for that question. See, I've got another question. It says, in my plant, we're still using a lot of paper. How do I go about getting rid of it all, moving to a purely digital experience? I mean, that kind of goes back to, well, dovetails with the last question, but it also goes into the point about digital maturity and establishing a roadmap, and then charting a course. Don't try to bite off more than you can chew. Establish waypoints along the journey, like proof of concepts, and then making sure you're setting yourself up for success at each step, and not moving in a direction that is contravening your strategy. You can adjust your strategy along the way, but making 180-degree turns is not going to set you up for success. And in this way, you're moving in smaller steps towards achieving a complete digital experience. Another question, operators are used to doing things manually. How do I get them to use these new digital systems? I think this one goes back to that point about keeping people at the heart of the process, making sure you're involving your operations in your road mapping, and then getting those operators interested in the changes that are coming by asking their opinions and getting them involved. I'd be surprised at how much people will appreciate new systems if they have a stake in the game at the very beginning. And then another thing to add, I would say, would be training. The workforce needs to be trained to perform the tasks that they need to do. So, make sure you update your training programs, to include those new technologies. Okay, I think that is the last question. So thank you, everybody, for attending this session. If you have any further questions, you're welcome to email info@grantek.com. And, at the